are going over it. So hopefully you guys did what the do now said and you looked over function g of x. G of x is represented as a table and as a graph. So from either one, you should have been able to find things that are asked of you. So up first, it asks for you to find the domain. Well, because g of x goes forever to the left and right, the domain is infinite, negative infinity to positive infinity. The range, I do. The range is what? Oh, the range is from low to high. So my lowest value is -8 and my highest value is infinity. So there is a point defined at -8 and then it goes to infinity. So the type of function that we have, it's a positive. It's a positive even degree. And that even degree is 4 because we have 1, 2, 3 turning points, and your degree equals your TP plus 1, your minimum degree, right? So therefore, we have a positive fourth degree. Uh, the reason why it's positive is because your right hand in behavior is positive. Remember, your right side determines your leading coefficient. So my right hand in behavior is going up to positive infinity. That means my function is positive. If my right hand in behavior is going down to negative infinity, that means my behavior is negative. Even functions, even behaviors, odd functions, opposite behaviors, right? All right, zeros and their multiplicity. So this is the word that I said I wanted to make sure we understood. So a multiplicity is how does your function behave around the x-axis, right? What are your x intercepts doing? So when you have a function that is just crossing the x-intercept, that's a single multiplicity, right? It just drives through. It's like boom, bam, I'm done. Okay. When you have a zero that touches or is tangent to the x-intercept, x-axis, I'm sorry, that's called a double multiplicity. Okay. What that means is that its factor is squared. So we have our zeros. We have a zero at, oh, I forgot this corner doesn't like me. I can't write accurately in it. So great. So we have at, okay, it's too early for this. Let's try that again. At, okay, we have one at x equals -5, and it has a multiplicity of 1 at x equals, okay, I don't want to write there anyway. That is so weird that I can't write in certain parts of the board. At x equals -2, and it has a multiplicity of 2. And we have one at x equals +2. Like, is the deal. And it has a multiplicity of 1. Sorry, the highlighter didn't. Okay. So again, when you have a multiplicity of 1, I'm just a regular x-intercept crossing. Multiplicity of 2, we're tangent, or I call it kisses the line. So it's going to kiss the line. Now, multiplicity of 3 looks a little different. We don't have one on this graph, but I am going to model it for you. Multiplicity of 3 is, that didn't go very well. I didn't even cross it. I'm just gonna graph it for you. That sounds like a better option in life than me trying to draw it. So let's do that. Where's Sylvie? There she is. Hey, girl. All right. So when you have a multiplicity of 3, what that means is that your function's factor, let's say I had x minus 3 to the third power. The factor has a power of 3 or a odd power on it. So we have the single with 1, bless you. We have 2, which is an even multiplicity, and an odd multiplicity. So when you graph it, you see how it kind of slows down and then smooths out and then comes back? There's a change in your slope right there, a brief change. I call it a drive-by. It's going to slow down as it gets to the x-intercept and then speed off. Does that make sense? So that's why I call it a multiplicity of 3, a drive-by. A multiplicity of 2, I call it a kiss because it's just a little peck on the line and keep rolling. Okay. That means that you're not, your signs of your y values are staying the same. Does that make sense? So notice here that our y stayed negative at this point instead of changing from positive to negative or negative to positive. Okay. So that's what it means when I ask you about multiplicity. All right. Continuing. The reason why it's on this notes is because the notes I chose to use this year for this section, they did not explicitly review multiplicity because they assume that it's stuff that you should already know from Algebra 2. Whereas previous years, I have gone and reviewed it in detail. But here we go. Your intervals of increase, where g of x is increasing. Remember, when you're increasing, that means you're describing what's happening to your graph from left to right. So when I'm reading this graph from left to right, I have a decrease, an increase, a decrease, and an increase, right? So from left to right, my intervals of increase are from here to here. When you're describing your intervals of increase and decrease, you are using your x values because x marks the spot where they begin, okay? So my interval of increase is going to be from -4 to -2. And that U means and. It's going to be from, looks like 1 to infinity. Yes? How do we do? No? All right, your interval of decrease, again, reading from left to right. We're going from negative infinity, and we stop at -4. And we are going from -2 to 1. And that should have been what you wrote for your interval of decrease. Your relative maximum, again, that's a point where you're changing from increasing to decreasing, right? So looking at our graph, our relative maximum, I'm going to highlight it on my new graph here. We have a relative maximum, only 1. Hopefully you only wrote 1. Okay, our relative maximum is at x equals -2, and at that point, y equals 0. Okay, our relative minimum. So finding your relative minimum, you have 1 and a 2. For your relative minimum, we are at x equals -4, and at that value, y equals -4, right? And at, why wouldn't it let my at symbol make it? At x equals 1, and the y value is -8. X marks the spot, y is why you're there, okay? Do I have an absolute maximum? No, because I have these little things going on forever at the top. I do have an absolute minimum. What is my absolute minimum? Y equals what? -8, right? My absolute minimum is at y equals -8, all right? So then it says, how many points of inflection are there and how do you know? Okay. Remember, your points of your inflections are describing the point where your slope is changing, correct? So that means you're looking for when your function is going from concave up to concave down and vice versa. Okay. So I'm going to use the highlighter to mimic these points. I'm going to use orange to model when I am concave up. So notice that I am concaved up from here to here. I'm also concaved up from here to here. Okay, then I have points of concavity, being concave down. So it's concave down from here to here, right? So how many points of inflection do I have? I have 1, 2 points. 2 points where the concave up and concave down intersect. Do we see that? I'm not going to write in words. I just said it out loud and I modeled with highlighting. How do you know? 2 POIs. Okay, then it asks on what interval where g of x is concaved up. In order to find the interval, I'm going to have to find the POI for each one. So here, I'm going to just call this P1, and I'm going to call this guy P2. Remember, to find our POI, all we're doing is find the average, right, between our max and min points. So our first P1, that's going to equal, we are at -4 plus -2 divided by 2. Those are my x's, and then my y's are -4 and 0, right? Plus 0 divided by 2. So my first point of inflection is at, what's -4 plus -2? -6 divided by 2 is -3. -4 plus 0 is -4. -4 divided by 2 is -2. So my first POI is from -3 to -2. So I can say I'm concaved up from -infinity up until -3. Does that make sense? Okay. I have another point of being concaved up, which means I have to find my P2. So for P2, I have -2 plus 1 divided by 2. And I have 0 plus -8 divided by 2. -2 plus 1 is -1. That leaves me with -1/2. 0 plus -8 is -4. -4 divided by 2 is -2. So my second POI is at -1/2 comma -2. So now I can describe where my second point of being concaved up is at. It starts at -infinity and it continues at, but not -infinity, -1/2, and it continues to +infinity. That's my interval of being concaved up. Now it asks for your interval of being concave down. So your interval of being concave down is between your two POIs. Agree? So I'll be concave down from -3 to -1/2. Okay, for the ones who actually did it on their own before we got started, how did you do on putting and summarizing all of our knowledge? Got a thumbs up in the front. Okay, if you did not do well in the beginning, are there still any points of confusion that you need me to highlight, address, or go back over? None? Look, I'm not gonna make y'all talk to me. I'm dying up here, so I'm gonna keep going. All right. All right. Next is graphical reasoning. So what happens? This is leading up to our FRQ number 3 once we get to the actual test. So it's not a polynomial function, it is a sine function. But with that function, you have to be able to take whatever values they give you and problems they give you, and you have to be able to place them correctly and analyze it from there. Okay. So we're like kind of baby stepping into that. It's called graphical reasoning. However, again, it's for a trig function, not a polynomial function. Okay. But we're going to practice seeing it in that format. of a blank graph with A, B, C, D in place for us to figure out what each piece represents. Does that make sense? Okay. You're not going to see the real FRQ3 until the spring because that's when we learn about trigonometry. But the graph here is a function P of X, and we're going to use it to answer the following question. It says, is the rate of change of P of X increasing or decreasing at point A? So at point A is asking you, is the rate of change, not the function itself, but is the rate of change increasing or decreasing? Meaning, what is your slope doing? Like, right, your tangent slope at each point doing at point A. Is it increasing or decreasing? We have one person who says decrease. Anyone else wants to take a stab at it? So remember, you're analyzing the slope. Is it getting steeper or is it getting steeper? Is the line doing this? Like if you have your tangent, let me draw it. Maybe that'll help. So when we're looking at this, this is where we're saying at each point, that's not very straight. I really need them to install this program. Please be my friend. I don't ask much. But if they give me the other program, I actually can draw straight lines, like intentionally. Okay. We're gonna pretend that this is it's kind of straight. It's gonna be as straight as it gets, guys. But it's asking, is your state, what is your slope doing? Is it leveling out or is it growing? Well, what it is doing here is it's a positive, 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 and then it's gonna become what? Zero, right? When I'm at that maximum, that means my slope is horizontal. That means that line is like this, right? That tangent line is a horizontal line. And if I'm a horizontal line, then that means my slope is zero, right? So I went from being positive to zero, which means that I had to be decreasing. Does that make sense? So at point A, your slope is doing what? Decreasing. Your line is increasing. The function itself, the y values are increasing, but your rate of change is decreasing. Okay. A lot of times we get that confused. Exactly. And because it's at an interval of where it's concave down. Okay. So let me highlight the concavity here. So if you look right here, this is on the piece of the graph that is concave down. If I'm on that piece of the graph that is concave down, that means that my rate of change has to be decreasing at any point along that line. Does that make sense? Yay, nay, maybe so, sometimes. Lady, it's not a Monday, but it feels like a Monday. Why are you making us do this? Kind of mindset. Get over it. We're all going to struggle together. Okay. So the best way we're going to write this is at point A, the rate of change of P of X is decreasing. Since the graph of P of X is concave down. And that would count as a justifiable answer. Okay. You do not want to describe it as the slopes are changing. No, we don't use slope. We use what? Rate of change, right? So even though in our brain in algebra 1 they drill rate of change is slope, we're gonna use you must use rate of change because we're not talking about a linear equation. These are the only guys with with slopes. Okay, we're looking at rates of change, and you have to describe the concavity. Okay, that's how you get the full points on an FRQ that was asking you about whether a function is increasing or decreasing based on a rate of change. Okay, so let's see if we caught on. So now at B, What is the rate of change at B? It's going to be 0. So rate of change at point B is 0. And why is it 0? Can't say it's horizontal. What's happening at that horizontal point? What is the graph doing at that point? It's constant, but that's because it's changing from increasing to decreasing. It's at a point where the graph is changing. It's the y values are changing. Does that make sense? So we write because short amount of words. Because the graph is changing from increasing to decreasing. Yeah. Because P of X is changing from increasing to decreasing. I don't know what happened there. I'm not going back. All right. What is happening at P? I mean at C. It it is, and why is that? Okay, it's the approximate average between the extremes. What they're going to be looking for is that it's where your rate of change is changing from decreasing, which means that it's going from being concave down to being concave up. That's all they want you to be able to say. Does that make sense? So in words that they want, so that we're like getting all those points, because remember every FRQ you get a point, right? Or half a point. And we want to make sure that we're getting at least 1 point for every FRQ. If you were to get majority of the multiple choice right and get at least 1 point for each FRQ, that's basically a 4 for this test. Yeah, it's not like you got to get every part of the FRQ right, but if you can get at least 1 point off of each piece of the FRQ, and not even really majority, I would say like 50% of your multiple choice correct, then that's a 4 for this test. Because it's making sure that you understand vocabulary and analysis. That is the part of the test, okay? If you, let's just say you didn't do any FRQ, but you kill it at multiple choice, that's a guaranteed 3. So imagine just answering some of the FRQs if the multiple choice is a guaranteed 3, and you just answer some of the FRQ and explains well enough using the right words, you can easily sit at a 4. Okay. This test isn't about like, it's not meant to be rigorous. It's meant to be a true assessment of did you take in and process what was being taught in the class. Okay. That means the vocabulary, the formulas, the definitions of everything. And can you repeatedly apply it over and over to different functions? So just keep that in mind when we're having to write out our explanations. I'm trying to be very particular about the words I use so that you get used to seeing those words and that you don't get used to like lazy writing or um, using the wrong terms, because then it's on me that I lazily told you that. But yes, so the answer is point C, consider point of inflection. The answer is yes. And you can write it as it's the point where, that's not you spell where. That's the wrong where. It's the wrong one. I know. Don't tell me. It's the point where P of X goes from concave down to concave up. That's an option of writing. You can also write that it's the point where the rate of change goes from decreasing to increasing. Okay. So either you can talk about the concavity or you can talk about what the rate of change is doing. Either one of those are sufficient answers. Make sense? Okay. But we can't just say it's the max, it's the average point between the max and the min. That will not get us the points. Okay. Even though that's how it's calculated, we can't say that that's what it is. Does that make sense? Okay. All right. So next, is the rate of change at point D positive or negative? And the answer is positive. And why is it positive? is positive because what? It's concave up because P of X is concave up, or you can write that, or the rate of change is increasing. Is increasing. Our magic word, though, for this course is concave, concavity. That's our magic word, okay? It's the newest vocabulary word that you'll hear in this whole first semester, okay? Everything else should be like roughly a repeat of something you've already heard, but that's going to be our newest.